So now I explain how to do experiment in the given distance relay kit. The main objective of the experiment is to calculate the distance relay settings and perform the fault testing on a given numerical distance relay kit, which is connected to the transmission line prototype. Of course, the result is to be verified by comparing them with the more relay characteristics and the impedance locus that we will explain in detail further. So the figures show the circuit diagram, which is same as that in the relay kit, which consists of 4 impedance Z1, Z2, Z3 and Z4. So one question is taken to demonstrate the experiment with the help of the software and hardware. The question is, in a given transmission line, the distance up to F3 is considered as 100% of the primary transmission line. So calculate the settings required to trip the distance relay in zone 1 for a fault at F2. In other words, means when a fault is at F2, the relay will trip in its zone 1 area. Additionally, also determine the settings necessary for a delayed trip in zone 2 for fault at F3 and also at F4. Means if for a fault at F3 and F4, the distance relay will trip, that is for a delayed trip in zone 2. And the tripping time is also mentioned. The zone 1 tripping time is 0.1 second. Zone 2 is in a delayed tripping time for around 1 second. The solution in detail is, these are the required data for distance relay settings. The line parameter, that is the line impedance corresponding to a 100 kilometer line, because in the software we have to be given the impedance corresponding to the 100 kilometer of the line. That is also considered as the 100% of the primary transmission line. In this case, the primary transmission line is up to F3. Therefore, Z1 plus Z2 or ZL F3 is considered as the impedance of the primary transmission line, which have to be measured experimentally. We will demonstrate in detail in the next section of this video. Therefore, the impedance up to F3 is to be measured experimentally. Next is the zone settings, that is the settings for zone 1 and zone 2 must also to be calculated, which is also taken as the percentage of this ZL F3. And the further reading required is that for zone 1, already explained that F2 is in zone 1. Therefore, we want to know the impedance up to F2, that is ZL F2 is also to be measured experimentally. And the question itself, it is mentioned that the fault at F3 and F4 are in zone 2. Therefore, F3 is already to be found out experimentally. And next, we want to measure the impedance up to F4, that is ZL F4 must also to be determined experimentally. The calculated impedance value will be then used to set the distance relay reach for each zone separately, which will ensure the correct operation under both near and remote fault location. So in the experiment, this is the tabular column 2, which will enter the impedance up to the fault point, that is for a fault at F2, measure the impedance, that is RF2 plus JX2, similarly F3 and F4. After that, the impedance in percentage with respect to 100% of the primary transmission line, that is in all this case the denominator is ZL F3. In F2, the percentage A is ZL F2 divided by ZL F3 into 100. B is, of course, it is ZL F3 by ZL F3 is 1. B is taken as 100% and C is more than 100% because ZL F4 is greater than ZL F3. F3 in this case. So based on the above data, the characteristic line and impedance angle can be drawn. All these things, it is assumed that the expired ratio of the transmission line remains constant throughout this entire length. So now it is a time to familiarize the relay kit, and after that the software is introduced to explain how the kit is used to find the fault impedance at F2, F3 and F4. While opening, two modules is available here. To measure the fault impedance, please click on the measure transmission line impedance icon as visible here. This is a window for this experiment. So in the kit, the patch cord is connected from the banana terminal, which is residing in the upper position of the fault switch, to the point where the fault impedance to be measured. In this case, at first F2 is the fault point. So next is to establish a connection to the relay by clicking this icon. Now the connection is successful. The important point is that anytime you connected the USB cable from the kit to the computer, the next procedure to push the reset button in the kit. Otherwise, the display shows relay not found, unlike this connection successful message. So if that message will come, please reconnect the USB cable again and press the reset switch. Then by clicking this establishing a connection to a relay, again this message will pop up like connection successful. After that, you are in a position ready to find the transmission line impedance by clicking just this measure line impedance. So fault will created at the kit, and the message shows that the resistance up to the fault point is 1.45 and reactance up to the fault point is 10.17 respectively. So what to next is that reset the please click here to pause, then click on this reset relay. Now you change the patch cord position from F2 to F3 and again do the experiment for F2 and F3. Please note the reading and tabulate the reading. Here the reading from the conducted experiments are tabulated as shown in the second column of this table. Further, the value of A, B and C are calculated based on the impedance and shown in the third column of this table. Based on this, the characteristics line is plotted and the point corresponding to A, B and C are marked. To ensure proper operations, we know that the fault at F2 is in zone 1 and the fault at F3 and F4 are in zone 2 of the distance relay. Therefore, it is easily found that the zone 1 relay settings should be greater than the A and also should be less than B. Therefore, satisfying this condition, A less than zone 1 setting less than B. Therefore, zone 1 setting is taken as 70%. Similarly, to cover fault at F3 and F4 within zone 2, the zone 2 relay setting should be greater than value C. Satisfying this, zone 2 setting is greater than C and therefore the zone 2 setting is considered as a value greater than 135%, that is 150%. And the corresponding more characteristics are shown in this figure. This blue shows the zone 1 and the other color shows the zone 2 of the distance relay. Whenever the impedance locus falls into this inner circle, the zone 1 will act and interrupt within 0.1 second, and whenever the impedance locus reach in these regions other than zone 1, the zone 2 will act and trip within 1 second. We already calculated the distance relay settings and the resistance and reactance of the 100% or 100 kilometer of the line. So it is a time to do further experiment in kit and ensure that the fault will come to the corresponding zone region. So open the software and click on numerical distance relay experiment. A new GUI will open here. You can see that the status of the breaker, the graph, real-time fault graphs, zone relay characteristics, distance relay, etc. etc. First of all, click on the established a connection to the relay. A message like connection successful. Please enter distance relay settings and click on update settings to the relay is appeared. Please be ensured that only after entering all the settings, then only click on the update settings to the relay. Now you have the readings. The 100 kilometers line resistance is 3.59 and the reactance is 22.06. The zone 1 coverage is 70%. Zone 2 coverage is calculated as 150%. Zone 1 tripping time is 0.1 second and zone 2 tripping time is 1 second. So after entering all the setting, you can view the CARA based on the setting you entered. The interactive thing is that you can zoom on this CARA and you can read the R and X value in each and every point by clicking on the cursor on button. So this is the resistance and the reactance value at this point. Cursor off and zoom off, reset the view. So here the breaker is now inactive. Circuit is inactive now. That the status showing is that both the breaker, fault switch and the R1 breaker shows white color. After click on the update settings to the relay, the breaker R1 is turned on. That you can visible from the relay kit and all the LEDs are turned on. And in the circuit breaker status, the fault switch is in open. There is no fault is initiated. That show green. And red color in R1 breaker shows that the breaker R1 is turned on. Click on the plot waveform button, shows the value, voltage, current, resistance, reactance and trip signals in real time. The plot is in real time and numerically you can view the values of resistance and the reactance value. And in the mock relay characteristics, a small dot will appear, that is the real time R and X value. Now fault can be created. Fault is created in the kit by connecting the patch code to the F2 point. Already know that the F2 point, the fault is in zone 1. We want to verify that. To verify that, click on the fault insertion button. Now fault is created. Current will be shoot to a higher value is around 13 ampere. Resistance and the reactance value will be lowered and the trip signal is initiated. A pop-up window is also appeared that the resistance up to the fault point is around 1.48 ohm and the reactance is 10.11 ohm. It is verified that the fault is in zone 1 because we created the fault at F2 point. Fault distance is come around 46 kilometer. And the impedance locus nicely enter from the initial point to the zone 1 of the relay. The real-time view of the more characteristics also can be visible. For documentation, first of all, please click on the generate report. Before that, close this window by please click here to close window. And to analyze the waveform further, click on the zoom on button here and just drag horizontally and you can enlarge the waveform on a smaller time scale. The strip signal is generated after 0.1 seconds. On generate report, please click on the generate report window and you will save it as distance result 1 and saved. PDF saved successfully. And you can open that PDF and view the relay settings, result, distance relay plot, waveform, etc. for further analysis. So now it is a time to reset the relay. Click on reset relay. Will reset all the waveforms, plot, settings, and breaker status shows now the initial white color, and all the LEDs and R1 breaker and fault switch are turned off in the kit. And again, you can perform the experiment for a fault at F3 and F4 and verify that the tripping happened in zone 2.